Hey everyone, Eric here from Iowa Robot Fighting. So we're going to go ahead and continue the So You Want to Build a Combat Robot part 2. So this is the next episode where we're actually going to go into the details of what it takes once you have the parts to be able to put it together and get your first test robot really rolling. I have a handful of components here that were shown off in the previous video. The previous video had a list of required components in the description. There will also be a list of components, these same components, in the description of this video as well. If you need greater detail as to what the components are, what they do, there should be a link right up here that should be popping up somewhere above my finger. You can click on that, go to that video, and you can see the breakdown and costs and things like that. In that video, I actually draw attention to a set of batteries that I do not recommend now that I dove a little bit deeper. So they do not have a compatible connector to the connectors that are needed for the speed controls. So you would have had to have done some wiring, which would have been a little more difficult, which requires more equipment and more effort and all of the above. And it makes for a more interesting experience, but also a more tedious experience for those who haven't built one of these before. So I swapped over what's recommended in the description and labeled it as such. In the description of this one, I will have a link to the batteries that I bought for this video. So all of the components I have here will be listed and are the suggested first step components. So last video was the breakdown of costs for this potential robot, my robot, and all of the necessary components that you need, running all the way up to a higher energy robot, and what all of those components do. Now, this video is the basic build. The video to follow will be how to apply these parts to an actual combat robot build. One that could actually enter the arena, not necessarily win, depending on what it's going up against. It could have some victories, but it's a good first place to start because of trying to keep down the costs. And I will go through the process of showing you what tools are required. I'm going to try and keep the tool costs low. I won't be using like my bandsaw or my drill press or a 3D printer or anything like that. Although I will probably go through what some of those builds might cost, and I can walk through the process of those as well. So let's dive into this video right after I tell you about my latest merch. So I don't have the site up, be on the lookout for that, but we are adding a site specifically for buying sweatshirts and t-shirts and everything that we will be using at tournaments and that you see on the show on me. Currently we have an existing site, but it doesn't have the variety that I'd like. I'm a big zip-up hoodie guy, and I've wanted a Iowa Robot Fighting hoodie for a while, and I'm pretty happy with this one. It's nice and light. And this will be available on that site as soon as it is. So sometime during the release of this series, I will show off that site where you can get those. Also, if this is the type of series that you like and want to see more of and want to see Iowa Robot Fighting go more in depth and keep going with the Builder series, make sure to like and subscribe. It's the only real way we get feedback to find out whether our audience actually enjoys it. We have seen a major uptick in in subscribers from the last video. So I think we're on to something that you guys actually want. But if you're someone new or someone who tunes in regularly but hasn't subscribed and doesn't regularly like the videos, please do. So that way we know that we are bringing you content you actually want to see and, you know, aren't just a passerby. So let's dig into it. Electronics. So the last time I walked through this stuff, I was digging through, and let me grab a scissors here. I've got one up here somewhere. Do I not? Okay. Time to do it the caveman way. Okay. So last video we had, I showed you guys the ESCs. Now these are brand new ESCs, just like you get out of the box. Obviously you saw that I opened them myself. This is the wiring configuration, and this isn't what I would personally bring to an event. I would do some wiring and some cleanup here because there's this switch on it, but no need to do that for the first build. And then obviously your motors. Which I recommended as 200 RPM motors like this. So ESCs, motors, which need to be wired, as you can you might be able to see that here. There's some little electrodes, and I used the word diode last time. It's electrode. There's electrodes on the end. Dispose of some trash. And then the much vaunted batteries. So I originally recommended getting one, but two is the best way to buy them. And this is the necessary connector. This is a, what do they call it? A JST connector, but it's actually a type RCY connector. Don't ask me why they call them that. RCY, that's why. This plugs into this connector here. So this is your electrical feed. There is a connector that needs to be produced in order to get power across to these multiple speed controls, which I will walk through, but these batteries should have enough of a charge initially to do what we need. Lastly, for the main electronics, we have a brand new radio. Brand new radio. Ah, love it. This is the exact radio that Evan uses. I may or may not be swapping to this particular radio. You can see that's a stationary antenna, some cool little components, and then it obviously comes with the FlySky receiver, which is the internal component that's required. Let's get this stuff out of the way. Okay, so comparison-wise, you can see that this radio is slightly larger than this one, and it's slightly heavier, but the functionality of these radios is very, very similar. So let's get into the receiver. Now this is a slightly smaller, slightly lighter receiver than what I am used to using, which is no big deal. It's actually perfect for a robot like this. It's got twin antennas. I'm not sure if that's really necessary, but it is for this particular receiver. Let me get some batteries in this thing. Ooh, and that's a different feature. Okay, so you can see that that takes 4 batteries, whereas this other one that I tend to use takes 8, which is absolutely insane, and that burns through batteries really fast. So apparently this one is a lot more efficient as well. So that's cool. And power on the radio for the first time. Okay, so you can see that it's presenting me with a warning. This warning says that I've got some sort of setting on here that's going to, when connected with whatever receiver, it's going to be providing input to give power. So most likely it is, there it is. So for the off position, for most of these switches is up. So if I have this off and the power is up on what would be the throttle for an airplane, it'll give me a warning until I reduce it to 0 power. Same goes for any one of these switches. If it's not in the off position or the low power setting, it'll give you a warning and won't provide any transmission until that's the case. So that's a little thing that you might not be aware of right off the bat. Okay, so this is set and ready to go, except we don't have it tuned to the receiver, which we'll worry about in a second. So the hookup process for this. So you've got your receiver here. If you're not sure what needs to be hooked up to where, the quickest way to figure that out is to go into your settings for this, which I need to figure out. There we go. For this radio, you press and hold the OK button, which is right here. It will take you to these settings, and you go up and down on this rather than what I had on my other radio, which was a spinner. So you go to Setup, and then you go to Display, and that will show you the feeds from a given position. You can see that side to side provides input to channel 1, and up and down provides input to channel 2. So we want to hook up our speed controls and motors to channels 1 and 2, and then we'll get into some setup later to do what's called channel mixing in order to have this provide information to both speed controls at the same time for what are called tank controls. So that way you have a single stick controlling the motion of your robot. Okay, so now we know channel 1 and 2. On your radio, you will see channel 1 and channel 2, or your receiver, I should say, you will see channel 1 and channel 2 at the very bottom, these pins. That means that you can hook up, so you've got your speed control, you've got your 3-pin connector, you push that onto the 3 pins with the silver side up, 3 pins onto channel 1, and onto channel 2. Good. Okay, so your speed controls are hooked up directly to your receiver. Now, what do we do about the motors connecting to your speed controls? That's where this pack comes in. This is another pack of RCY connectors that you can buy on Amazon, which are also listed in my description. These will need to be the female connectors that are in this pack attached to your motors. Now, you don't necessarily have to solder them for this particular build, but you are going to want to when it comes time for building the actual combat robot that you're going to take into the arena. Now, you're going to need either a wire cutter or a stripper. So for my purposes, I prefer one of these vice grip strippers. It allows multiple gauge wires to be stripped with this, and I'll show you what that's like. But for the purposes of simplicity, you might only have at your disposal a small wire cutter. One of the other little stripper devices that you can get is this little ring stripper here. It's a pinch. You feed the wire in, and you can just circle around the wire and pull the wire off. This works for a little bit larger gauge wires. And then there's the tried and true wire snips, and also pliers with wire cutter on it. Now, mine isn't that great. It's actually gummed up pretty bad from years of being out in the garage, so I'll show you what it's like with a regular wire cutter. So we don't need these very long, so we'll cut these down. Let me move some of this out of the way. We'll cut these down, and then we'll go ahead and gently grip these and spin. And what you're doing is you're cutting the insulating plastic off. And then once you've got it scored, you can pull and expose the wire just like that. And take some practice if you've never done this before. And I'm kind of out of touch with doing it with more in-depth, like a heavier duty one. What you're going to want to do is, as soon as that wire is exposed, spin it. So you'll want to grip it and spin the wire in your hand. And this will keep the wire from fraying and ensure you get a nice clean, especially when you're soldering, a nice clean wire. You don't want frayed wires sticking out, because if you have that, you're going to end up with a potential short somewhere. And I've got video somewhere in my collection of one of my robots lighting on fire, specifically because of a shorted wire. It's happened plenty of times to me. It's not always something like this. It's a lot of times an electronics short, or like battle damage has frayed some wires, but that happens. Okay, so now, I don't know if you can see in the video, but you can see a positive, a plus, inside a circle on the back of these motors. So you'll want to take your red and thread it through. I'm shaking pretty bad here. Thread it through the side that has that plus, the little electrode that's in there. And with the size of these, the gauge of these wires, you might actually have some fraying occur. Now, when doing a loose fit like this, it's almost always a good idea to also have some of these heat shrink tubes. So you can get a set of these. I have these in the description as well. This is a set you can get that is relatively inexpensive. I think this is like $5 for all of these. So for the black connection, I'm going to cut this down to size. I'm going to slip one of these wires through my connector here. And then I'm going to go ahead and do the same thing, slip that through, do a quick twist, and then I will slip this little heat shrink over top. Now, I should have done it for both sides, but you also need a lighter or some heat source. And what we do is we then apply heat, which will then shrink this, essentially shrink wrap it, into place, so it's even less likely to slip. Just like that. All right, there you go. And if we did that to the other side, it would ensure that that connection is less likely to slip. Typically what I do is I solder, then I slip that over and heat that up so that I protect that connection. It also adds insulation back into the mix, ensuring that we don't have to worry so much about a short occurring. So we got one. Let me show you what it's like with the vice grips now. So we'll go ahead and again clip these down. And now I'll feed this into the correct gauge. See how much faster that is? I'm not worried about cutting through the wire because there is already a hole that's the correct size. Okay, and now I'm going to do it properly for this one. So I'll take my shrink wrap tube, and I'm actually going to cut this down even more because I don't need quite that much. So I'm not going to have all that much exposed wire. Slip that through, make sure I didn't fray my wires again. One of the things you can do is bend the wire out of the way so that you have room to work. Then we'll once again look at the plus on the back here. We'll feed the red through the plus side. Stop shaking, Eric. And then my lighter. And I'm applying heat to my own hand. Look at that. Gotta love it. Okay. Get this back over here. Sometimes you might need to have a second pair of hands to hold it when applying this. There are little devices that you can get that will hold wires and electronics in place for you. And I have one, but I don't want to show you guys anything that isn't absolutely vital to the creation of one of these little test robots. And I nearly forgot the little shrink wrap piece. That is a common mistake that if you watch some of our build videos, I tend to make that mistake a lot, and so does Evan when doing electronics. And I've got some fraying here. It's not quite working the way I want it to. Because you want to make sure that all of those wires are enclosed in the shrink wrap tubing. Because if you don't, then you end up with exposed wires anyway, and then it is far from ideal. There we go. Okay, so now we've got the shrink wrap on both. Not perfect connections because they're not soldered, but it should maintain connection enough to show the control of the robot. So now, the next thing is providing power from one battery to two motors. In this instance, you want to have a type of splitter electronic connection that takes the female connection, so the power connection, and splits it to males, just like that. Now, I am not going to go into actually creating this on camera, but I will show you what goes into it. And it's very simple. If any of you want me to do a quick video of the soldering process or anything like that, because I will do soldering in a later video, but not necessarily this connector. If you want me to go through the simple process of making this connector, I can. But really all you do is the same thing, just like I did for these. Strip all the wires, and what you do is you connect all the reds together and all the blacks together, and then you end up with this. So from here, we can then plug this into both of the male connectors into our speed controls for providing power, and then the male connectors out from our speed controls to our motors. All right. There you go. You've got two motors connected to two speed controls connected to the receiver. The last thing is the battery. You do not want to power up this without the radio on. That is a really bad idea. You won't have any sort of control, and if it isn't tuned up correctly, then there could be an issue, especially if you've got an active weapon. Bad idea. So let's go ahead and power on our radio, and it's not giving us any warnings. We will power up our receiver, which it's not doing anything. Oh, wait, switches. Switches are now on. We're receiving power. We've got a solid light on here. These are flashing. So that should mean we're not getting anything from our channel 2. Interestingly enough, the fix for that was to make sure that both of these switches were on. So for the first test, you might need to play with the switches to make sure they're right in the right configuration, but we are now, you can see we're receiving power there, and we're receiving power there. Okay, so that is ready to go. Next up, we'll go ahead and power all this down, unplug our battery for safety, and we'll set this aside. Last time I talked to you guys, I talked about doing cardboard, but to be honest, my favorite thing to work in is this ready board, which is what they call a foam core. You can go to a Dollar General, dollar store. You can look it up online. You can buy packs of 25 of it for 25 bucks, or you can go right to a dollar store and buy it for $1 per sheet. We don't need a lot of it, but of course, this is kind of an analog for cardboard because you can use the exact same thing. We can use cardboard if you like. I just prefer this. Okay, so we need a platform to secure our electronics to. So let's go ahead and create a small platform, just like that. Okay, that'll be our robot. Next up, we need wheels. So you can use any circular object you want. I'm just gonna use one of these little spools. I'm gonna grab my pen and I'll scribe a circle here. Just like that. Do a second one. Really simple crafting type of stuff here. All right, then you'll need a knife, or you could do this with a scissors. I prefer to do it with a knife because you can be slightly more precise and get a circular shape out of it. X-Acto knife would be better than one of these utility knives for sure. Especially not a dull utility knife like I'm using. But there's a reasonable facsimile of a circle. Let's go ahead and cut that down a little bit. What do I have? I probably have an X-Acto knife in my little airplane case here. Yep, there's an X-Acto knife. Let's go with one of those. Again, I'll show you what an X-Acto knife kind of works like, especially if you're not a crafty sort of person who hasn't done any of this before. Clean up this horrible looking circle. Okay, that'll do for now. Okay, and then X-Acto knife. So an X-Acto knife is exactly what it sounds like. It is supposed to be an exact cutting device that gives you more precision. For some reason, mine isn't wanting to do anything more than score. I guess all my knives are dull. Very dull. Okay, let's get around that, and then we'll make another pass. All right, that's a little bit better. Clean that up, and now we've got two reasonable facsimiles of a circle. All right, let's set this aside. Set my knives aside so I don't stab myself, because I'm likely to. And then we need to punch some holes roughly in the center of these. I would recommend using something like a screwdriver. You want the hole to be a little bit smaller than the diameter of our drive axles. So that way the friction can hold on the wheels. Okay, so we've got two holes there, two wheels. This is going to be a really janky sort of setup. Now I need some tape. Tape, Eric, tape. As one of my childhood heroes used to say, the handyman's secret weapon, duct tape. And if you guys aren't familiar with public television, I challenge you to go find a better show for a father and son to watch than Red Green. Look it up, it's hilarious. It's a Canadian television show that existed a long time ago. I don't think it still airs, but you can find clips of it online. Okay, so let's do this in the most ridiculous way possible. We need to secure the motors close to the edge of this platform. So set it down on the platform and duct tape your motors so that the axle is sitting just off the edge. And let's do the same for the other side. I almost just quoted another one. What's the Bob Ross with his happy little trees? You got a happy little motor right over here. Okay, duct taped motors on a platform. Super simple. All right, now be gentle with your electronics because we have some really loose connections, but go ahead and secure this with this wire and these switches sitting in a place you can access them. So we'll go ahead and do the same sort of thing and duct tape this down, again with the switches sitting separately. Okay, so now we want to make sure that the wheels press fit because I haven't tried this yet. This is my first test and I'm doing it on camera. So we'll go ahead and press fit that wheel on there and we'll do the same over here. There's a possibility that these might not be firm enough to do what they need to do, but we'll give it a try anyway. All right, let's get our radio, power that on, plug in our battery, and flick our switches. We're getting signal for both. And it looks like they're not quite strong enough to move. Nope, they're spinning freely inside the foam. Okay, so that is not a tight enough connection. So one of the other solutions is to try and secure these a little bit more. All right, so the solution to the dilemma is to use duct tape to actually secure to the axle. So push your wheel on just far enough so that you've got some axle exposed. Grab some of your duct tape here and place the tape on the wheel so that you can feel the axle through it. Then go ahead and fold it, touch and grab the axle, secure to the wheel and press down. You should now have a solid-ish connection to your wheel and axle. You do the same to the other side. That warning you're hearing is it having not sent a signal in a while, and it's warning you that yes, the radio is still on. Okay, so now we're secured, the wheels are on, and now it'll drive around kind of, sort of. It's not getting much traction. Let's try and get that kind of lined up. It doesn't want to drive forwards perfectly, but you can see it's driving around. Okay, so the next step here is to tune your controls just right. All right, so tuning the controls is pretty straightforward. So when it comes to seeing what the controls are doing, we showed this before, that you can go into display and get an idea of what each individual control does and on what channel. So this can give you an idea of what you want the tank controls to be. So when it comes to a regular set of controls, let me back it out here. So we're going to go ahead and go to a new set of controls, since this one is already tuned at this point while I'm filming here. So I'm going to select one to show you what it normally looks like. We use cancel held to confirm what we wanted to change it to. So now we're on Model 2. This is Fly Sky 2. It has a little airplane. Okay, so let's go back and show you display. So up and down on the right stick is channel 2. Right and left on the right stick is channel 1. So in order to give us tank controls, we need to go through a process of doing mixing. So we want channel 1 for 1 to be on, and for 2, that's all we really need for now. Leave that alone. So we press and hold cancel to confirm. And if you want to make sure that that sound was correct, there should be a little beep, higher pitch than if you just press cancel. But if you want to make sure, you can go back into mix and it should say on. So let's go to mix 2. Now this one's the weird one. We need to go through, turn this on, change this to channel 2 as master and channel 1 as the slave. Then we actually need to go backwards and set these to negatives. Now, if you've got reversed motors or anything like that, I'll go through what it would take to change that over without having to change your physical device, without having to change over your robot at all. Okay, we're just going to go to -50 on both of these for the sake of argument and confirm that. And now, when we go to display, now you see how that's split. we ended up with the opposite of what we want. So because of that, we can go to reverse one of these and go to display. And now they're both going in the same direction. But you remember the 50% that I put on? You see how it's only half the full distance. So when I go over, you see how this one's only going to half. That's not exactly what we want, right? So we need to go to our mix again. And we need to go through these until we bring these up to 100%. Okay, that's good. And then mix 2. There we go. And we confirm it. Go back in, make sure that it's correct. It looks like it is. And that's what cancel sounds like. Okay, so let's go back up to displays one more time. And now forward should go full forward, full back, and then split throttles, opposite direction. And that's all there is to it. Then any sort of tuning for like mixed up motors, just like we did before, you go into your reverses and change over either reverse 1, reverse 2, or both, and you can play around with it and see what's actually necessary to be able to get the robot to drive correctly. So there you go. Now you have to play with it depending on the robot you're building. This is obviously never going to hold up in an arena. And in fact, just for sake of argument, let's take a look at what the scale says. So for an ant weight, we have 1 pound requirement, right? So let's change this over to pounds, grams, and that's pounds and ounces. All right, so let's go ahead and set this on the scale and see where we sit. We are at a whole 2.5 ounces for this entire build. So obviously there's no armor, there's no weapon. This is purely electronics with some foam core on it and some tape. But what we just built was a really flimsy RC car. But it demonstrates the basics of the entire setup. But the next video here is going to be mostly filled with tool selection, part selection, and building a actual combat robot out of the parts that we have here. Not just a little toy or curiosity, but something that could actually go into the arena as a combat robot. There's going to be more that needs to go into wheel selection. You obviously can't use, well, you could use these foam wheels. I wouldn't if I were you. What I do, some of the more in-depth tools I use, some of the things you could do to get similar results rather than using the more in-depth tools. The tools that were required for this build: a wire stripper or wire cutter, a lighter, and an X-Acto knife or box cutter. Either way will work. Parts you needed were the electronics as spelled out by the last video, which you can again click on here, or the description down below. You can check each one of those and acquire the exact same parts that I used in this build. Some foam core, which you can order online or go to a dollar store, or you can just cut up a cardboard box and achieve the exact same thing. Get yourself some duct tape, scotch tape, whatever your preference is. I like the Handyman's secret weapon. And that is, well, take that back. I take that back. Also in the description, you'll find these connectors. I could have connected the wires directly to the motors, but that is not recommended at all. I would suggest buying a set of these, which are in the description. These are your RCY connectors. And then If you're going to continue to do stuff like this and you want to make sure that it's safe and as insulated as possible, also get yourself some heat shrink wire insulators, which is also in the description below. All right, that I believe covers it. If you liked the content of this video, you want to see us do more, and you want to support us, be sure to subscribe and like this video. It signals us very clearly that you want more of this type of build. I will get into in-depth construction next time for an actual combat robot, and won't require any sort of CAD or anything like that. It might require a piece of foam core for testing out, you know, what your build should look like, so that you don't waste a bunch of money on, say, aluminum or steel or whatever we're going to choose for this particular build. But that being said, thank you all for joining me. I hope you enjoyed this. I hope it was informative. You guys be safe out there. I will see you next time.